Okay, so in this problem, we're being asked about the function y equals the cotangent of 3x and where it might be decreasing. The first thing that crossed my mind is what does the general cotangent function look like? Let's ignore the 3x for the moment. The cotangent function looks like this with an infinite number of branches and asymptotes at integer multiples of pi, as we know. Because we're dealing with the cotangent of 3x in this point, this 3 is going to cause a horizontal compression by a factor of 3, which could be drawn physically by compressing this thing into something that looked smaller and tighter, but rather than doing that, I will just rescale my x-axis by dividing all the asymptotes by 3, thereby pushing in the function horizontally and achieving my goal. So now I know what the graph of the cotangent of 3x looks like. Let's get back to the question at the top of the page. We want to find an interval where we want to find a number p so that the function is decreasing on the interval from 0 to p. The answer, by the way, turns out to be pi over 3. And you can see by looking at the graph that this function is decreasing on the interval from 0 to pi over 3. And while that is the answer to the problem, let me expand a little bit further just on the thoughts that went into my mind as I was doing this problem. The question asked for the largest value of p for which that is a true statement. It's worth thinking about here, even though we're done with the problem, that this is a true statement for smaller values of p than pi over 3. For example, let's consider, for thought purposes, let's consider p being pi over 4. Is it true that this function is decreasing on the interval from 0 to pi over 4? Well, pi over 4 is smaller than pi over 3, and it is true that the function is decreasing on that interval. So this statement is true for infinitely many values of p, pi over 4 and pi over 3 just being two of them. But since we want the largest value of p, let's consider if p were bigger than pi over 3, say pi over 2. Would this function be decreasing on the interval from 0 to pi over 2? No, because if we look at the function from 0 to pi over 2, it's decreasing for part of it, and then it jumps up to the opposite side of the x-axis. And we can't say that this function is decreasing on anything larger than this. So again, the answer to this problem is pi over 3. But all of the discussion that you just heard was designed to convince you that if p were smaller than pi over 3 and still between 0 and pi over 3, that it would be a true statement. If p were bigger than pi over 3, then it wouldn't be a true statement. And therefore, pi over 3 is the largest possible value of p for which this statement is true. And that completes this problem.